Hi guys, it's Dr. Justin Southey here, going through your second semester test, and I'm on question number 10. Right, here you're asked to use the definition of the derivative to find f prime when you're given that f of x is equal to this function over here. So, using your definition, you've got f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h, of course. Now we just need to substitute this f of x plus h into f of x, so we get the limit as h approaches 0. Wherever you see an x here in f of x, you need to put x plus h. So we've got 3 x plus h all squared plus 2 times x plus h. Okay, that's just the f of x plus h part, is this over here, minus f of x, and now we just have the function as it is, so we've got 3x squared plus 2x, but of course we're minusing the whole of f of x, so that becomes a minus 2x, all divided by h. We need to multiply this out. The limit as h approaches 0, so now we've got x squared, but multiplied by 3, so that's 3x squared. 2xh, we get two middle terms there, times 3 of course, so that's plus 6xh. Plus h squared multiplied by 3, so that's 3h squared, plus 2x plus 2h minus 3x squared minus 2x, and of course that's all still over h. We're going to have some things that cancel out quite nicely here. We've got a 3x squared and a minus 3x squared. We've got a plus 2x and a minus 2x, and of course everything that's left over, as we expect, has got an h in it, and that we're going to factorize out and cancel with the h in the denominator. So let's do that now. We've got the limit as h approaches 0. On the top we're going to factorize out an h. We end up with a 6x plus 3h, one of the h's is gone, plus 2. Of course all divided by h, and now we can cancel the h's, and we're simply left with the limit as h approaches 0 of 6x plus 3h plus 2. It's a nice continuous function at h is equal to 0, so we can simply substitute in the 0 there, and we're left with 6x plus 3 times 0 disappears, plus 2. And of course you can check your answer, because if you go back, you know the derivative of this. The 3x squared differentiates to 6x, which we've got over here, and the 2x differentiates to 2. So we know we've got the right answer. You could also have done it using the f prime of a and using the x approaches a definition. Of course, then you end up with a function in a. You'd end up with 6a plus 2, and you just then need to replace it with f prime x is equal to 6x plus 2. Just a note on which method to use when. When you use h, you end up having an x plus h in your function, which generally you have to multiply out. So if you're good at multiplying things out, then use the h approaches 0 method. If you're very good at factorizing, then use the x approaches a method, because you end up with a expression at the top that you have to factorize to cancel away the factor with x minus a on the bottom. In this case, I think the h method is much easier.